Welcome back. In this video, we will be talking about water demand. It is the most important thing when we talk about the water supply facilities. Water demand means how much water is required for a specific purpose. It is not same throughout the day or month or year. It will be varying depending on the purpose for which the water is required. So, how to calculate this? Let the how much amount of water supplied per year is taken and is divided by 365 to get water consumed per day divided by population to give you per population per day, and you'll be writing it as liters per capita per day. Liters is the amount of water requirement per capita is per person per day. So normally we write like this. So if you look at the different types of water demand, domestic demand, commercial and institutional demand, industrial demand, public uses or public demand, and water system losses. These are some of the different types. Let us see one by one. The domestic or residential water demand. It is based on the day-to-day activities in the houses. So this is based on IS code 1172, and initially it was introduced in 1957, and where the different purposes of water requirement are identified: bathing, washing of clothes, water closet flushing, house wash, utensil washing, cooking and drinking, making a total of 135. At that time, there are not many utilities which are there in the houses. So based on that, some requirements have been identified throughout the country, and this is spread across all the seasons. Later on, the utilities are increased, the lifestyles have changed. It was revised in 1993, and then this was again categorized by adding gardening for 15 liters per capita per day, making a total of 200. And also see here the water requirement is increased from bathing at 55 to 75. Here, the number of facilities have increased, like shower facilities, water bath facilities, water tub facilities, and all such things have happened. And earlier, washing of clothes is a normal manual. Now we are having even washing machines, and water closets also now improved. So utensil washings also now, earlier it is 10, it is now 15. So even dishwashing also has come. Like that, a number of options have come. And more importantly, gardening has become one of the another activity. That's why it is also included to make it to 200. So animal washing is they also considered as 5 to 60 liters per animal. So how to characterize these two? So 135 is taken as minimum water requirement, and that is considered for weaker sections and LIG colonies in 1993. And the 200 LPCD is considered for Indian towns and cities. And Ministry of Urban Demand, they have also given some recommendations based on population. Less than 20,000 is 7,200, and greater than 1 lakh, 150 to 200 LPCD. So lesser population means the less availability of utilities. And that's why the water requirement is also slightly lesser. This is how the assumption has been taken care of. Institutional demand. It depends on various activities of institution, like hospital, restaurants, hostels, railways, and airports, cinema halls, etc. So hospitals, the total requirement of the water is estimated And then with respect to number of beds in the hospital, it is divided. So the amount is now calculated 350 to 450 liters per day per bed. This water is normally used for floor washings and clothes washing and the drinking and sanitation facilities in the hospitals. The restaurant similarly 70 liters per day per seat is expected. Hostels, they're like similar to that of residential demand, 135 LPCD. Railways and airports, here also around 70 LPCD is expected for bare minimum facilities which are there at railways and airports where water requirement is there. But because the amount of water demand is varying, so we need to have some average value for estimation purposes. So average value, you can take it as 20 to 50 LPCD based on some timelines and estimate and approximations. Industrial demand, every industry also will requires water, and that depends on the line of production they're making. And water demand for industries is calculated based on how much water consumed in the process and divided by whatever the unit of production they're making. For example, in the paper industry, they are producing paper. So the total water requirement per each ton of paper produced is considered. Comes to be 200 to 400 kiloliters per ton of paper. And this water is normally used for making a pulp, and that pulp is used to produce a paper. That's why the paper industries, majority they are located on the banks of rivers to take this much of water from the rivers. Automobiles, 40 kiloliters per vehicle manufactured, and then steel, 200 to 250 kiloliters per ton of steel produced. Sugar industry, 1 to 2 kiloliters per ton of cane crushed. Sugar industries, it is depends on how much amount of sugar cane crushed in the process. So that's why it is represented in terms of per ton of cane crushed. And for estimation purposes, because so much of variation is there, so the average value we consider as 50 to 450 liters per capita per day. And public uses means it can be road washing, sanitation, public parks, and firefighting. A small amount is required for road washing, sanitation, and public parks. For firefighting, we have two formula. It will be varying from city to city. The Ministry of Urban Development is given a formula Q is equal to 100 root P, where Q is in KLD and P is the population in thousands. And Kuchling formula Q is equal to 3182 root P. So, for example, if you are using a Ministry of Urban Development formula for a population of 1 lakh, it is 100,000. So, P is equal to 100 because P represent in terms of thousands. So accordingly, you have to substitute and then calculate the value of Q. So usually firefighting, we can estimate around 1 to 10 LPCD for larger cities. And to have an estimate to calculate for a city or a town, so we take around 10 to 15 LPCD comprising of all these things together. But remember, firefighting requires only during summer, particularly, not every time. But road washing, sanitation, public parks, they are maintained throughout the year. And that's why we have to take an estimate covering the overall water requirement here. And then per person or per capita population, we need to have this much of values. Water system losses for any system of water supply. Now there will be some losses. We have seen the taps are open and then the water will be lost. So, and then there will be some losses at the reservoir. There will be some losses during the transiting from the pipes. There will be some losses during the pumping of the water, and there will be some losses at the consumer point of view. So all these things you have to put together. We can identify that there will be some leakages from service reservoirs and overflows. There will be some leakage from main pipes and service pipe connections. There will be some leakages from public taps. There will be some leakages and losses at the consumer premises. But these we cannot directly account for, but we can take it as an approximate value, which is around 20 to 30% of total supply. The maintenance is not proper. This value may further increase to 40% or maybe up to 50% also. So to simple calculate a water demand for a city is now the domestic, industrial, commercial, public use water losses. We'll try to put these values here based on thumb rules, and industry here 40 to 450, and then 50 I'm taking here. That means assuming that the industries are very minimum in this area, and commercially is also minimum. So thereby we are coming to be 280 to 330 in liters per capita per day overall, the entire system losses we are taking here. And there's another guidelines given based on the population less than 20,000 and greater than 10 lakhs. Considering all these water demands, it is a minimum of 110 LPCD to around more than 330 LPCD. So this is how we normally calculate the water demand for a particular region. So we have to identify all the demands and then identify whether the industries are there in that area, how many institutions are there, and what type of facilities requirements are there. And all such type of things we consider, and then we take a bare minimum estimate and add all those things to come out with the overall requirement for the city. And this is what the municipal administration has to look at. This value, when you multiply with the population, will give you the overall water requirement for the entire city. That much of water required to be supplied for the entire city to satisfy all the needs. This should be the target of the municipal administration. And this is how we normally calculate the water demand based on the different purposes of water demand. Okay, thank you.